I'm a developer for a major food delivery app, and I'll explain how we use advanced debugging tools to solve critical customer issues. Let me show you the specific techniques we implement daily. When customers can't place orders, we lose money fast. Every minute of downtime costs thousands in revenue. That's why we rely on sophisticated debugging workflows. I'll start with our primary tool, Chrome DevTools Network tab. This feature shows every API request in real time. When users report checkout failures, I immediately open the network panel. I filter requests by XHR to isolate API calls. The status codes tell the whole story. Red status codes mean trouble. A 500 error indicates server problems. A 404 suggests missing endpoints. But 200 responses can hide issues too. I always check response payloads for error messages. Let me show you a real example. Last Tuesday, customers couldn't add items to cart. That Add to Cart button appeared broken. I opened DevTools and clicked the failing button. The Network tab revealed a 422 status code. The response payload showed invalid restaurant ID errors. Our front end was sending corrupted restaurant identifiers. The backend rejected these malformed requests correctly. I traced the bug to our restaurant caching system. A recent deployment introduced ID formatting inconsistencies. Next, I used the Chrome DevTools Sources tab. This feature lets me set breakpoints directly. I place breakpoints before API calls execute. Then I step through code line by line. The Variables panel shows object states at each step. For complex state management issues, I rely heavily on Redux DevTools. This browser extension tracks every state change. The time travel feature replays user actions perfectly. I can jump back to any previous state. Let me explain our production monitoring setup. We use Datadog APM for real-time performance tracking. The dashboard shows response times across services. Slow queries appear as red spikes immediately. When response times exceed our thresholds, alerts fire automatically. I receive Slack notifications within 30 seconds. The alert includes stack traces and affected endpoints. I'll share our mobile debugging approach next. For iOS issues, we use Xcode's network debugging. The network link conditioner simulates poor connections. This tool reveals timeout issues customers experience. Our backend uses distributed tracing with Jaeger. Every request gets a unique trace ID. These IDs track requests across multiple services. When checkout fails, I search by trace ID. The timeline shows exactly where delays occur. Database query optimization requires specialized debugging tools. We use Badger for PostgreSQL analysis. This tool identifies slow queries automatically. The generated reports highlight problematic query patterns. For Redis caching issues, I use Redis CLI monitor command. This streams all Redis operations live. I watch cache hits and misses happen. Pattern recognition reveals caching strategy problems quickly. Let me describe our A/B testing debugging process. We use LaunchDarkly for feature flag management. The dashboard shows flag evaluation logs. When features behave unexpectedly, I check flag assignments first. Our load testing uses artillery for realistic scenarios. I configure virtual users to simulate ordering. The reports show breakdown points clearly. Response time percentiles reveal performance degradation patterns. Memory leak debugging requires Chrome's Memory tab. I take heap snapshots during peak usage. Comparing snapshots reveals growing object counts. Retained size metrics identify problematic components. For production hotfixes, I use our feature flag system. Instead of deploying code changes immediately, I toggle problematic features off. This stops customer impact within minutes. Our incident response follows strict debugging protocols. I gather reproduction steps from customer service. Then I replicate issues in our staging environment. The controlled environment eliminates production variables. Stack traces get analyzed using our custom tooling. We've built parsers that highlight relevant frames. Third-party library errors get filtered out automatically. This focuses attention on our application code. These debugging techniques have reduced our incident resolution time significantly. What used to take hours now takes minutes. Customers experience fewer disruptions during peak ordering times. Our engineering team can focus on building features instead of fighting fires constantly.